We'll look at the stability, first question from December. We're asked to use the KN tables and construct a righting levers, GZ to 60 degrees heel, given the displacement and the kg. So starting off fairly standard, write out down the angles of heel, get the KN values at 9,000 tons, kg sine theta, get the GZ. Just alongside there I've written the righting levers as well as the GZ, simply because that's we're going to be involved in the second part. So first part fairly straightforward, and that's perhaps a bigger version of the sketch I've done there. Put my GZ values there. I just happen to have multiplied those by the displacement to get my moments values. And then of course the angle of heel along the x-axis. B, on departure we have a steady beam wind. We have to go to our data booklet and apply the heeling moments, the present condition. So in the table you'll see that at 9,000 tons we have heeling moments of 760. Now you can either apply that 760 to the y-axis if you've converted to moments, or divide that by the displacement and get the GZ value. Either way you should get the same answer. Once you've done that, we need our angle of steady wind heel, range of positive stability, max GZ, and angle of residual max GZ. Remember, with this line that you draw across, the horizontal line, it doesn't change at all. With steady wind heel, the 0.08 or 0.084 to be absolutely exact, but it's hard to put that on the scale we've got. Just draw a line straight across level. That will be our angle of heel. I got 7 degrees. That's the vanishing stability 56 degrees, so I got a range of 49. Max GZ would be the maximum value that you've calculated, of course less this 0.084, and the angle at which it occurs will be the angle of maximum. So I got 40 degrees and I got a value of 0.48, which of course is less the 0.08 that we've lost, that's below the line. So that's how I answered question 1. I thought reasonably straightforward question really, no real tricks. Question 2 has come up before, reasonably standard. Slight difference in that you're given the drafts, and of course you now have to work out your true mean draft and get values from the tables. So how I approach this question: AMD, TMD, go in the data booklet, get my displacement, MCTC, KM and displacement. That's my LCG for my tanks. Required trim, change of trim required. Don't forget to convert that to centimetres in the formula. And I calculated we have to transfer 115.4 tons, putting half in each tank. Then I worked out the listing moments on the vessel, worked out how much we had to transfer across from the centre of TCG of one tank to the TCG of the next tank, minus from port to starboard, and they were the final answers that I obtained. So questions 1 and 2 I thought, reasonably straightforward, not really any tricks there.